Hi everyone, today we're going to be building composite 3D animations using FXGL. So what you'll need to do is to get FXGL 11.17 into your project, and everything else we are going to do live. I'll very quickly build some boilerplate for us, something that we've already done before, so I'm not going to spend too much time on it. Just set 720p, set 3D to true, because we're going to create 3D shapes. This, in earlier versions, would have been called experimental 3D, so make sure you're using 11.17 or higher. In initialize game, we are going to create a cube first of all, run the application, see the cube, and then we're going to do everything else. Going to statically import FXGL, this thing, so I don't have to use FXGL all the time. Wait, entity builder, and view is going to be new cuboid. Build and attach. I think that's the only thing we need. So the cuboid comes from this package. It's similar to the box class in JavaFX, but it has extra methods to do some interesting things, which we're going to do sometime later. I think that's it. This is going to spawn a cube, and that's good for us. Yeah, so you can see a cube. We probably want to change the color scheme. So maybe change the background to something darker and the cube itself to something brighter. We also want to be able to move the camera around. I think it'll be nicer. And then we're going to animate the cube, which is going to complete the tutorial, as it were. Right, so get game scene, set background color to something dark, dark gray, and then I'm going to extract this cuboid over here, so I can set its form material and color. Let's go with gold, and then use the cube here. So we're going to essentially, we've changed the colors only. Let's see how this works. Yeah, that's a bit better. I'm going to move the cube down and then allow the user to be able to move the camera, because otherwise it looks like a rectangle. So because when we enable the FPS camera, so we can move, look around, we're also going to change the cursor to be invisible, so that it avoids all the artifacts, which means it'll be very difficult to get out of the game, which is why we need some input so we can easily exit game. On key down, key code, let's go for L. Game controller, exit. So every time I press L, I'm going to exit the game. And now we can safely turn on the FPS camera, and also get game scene, set cursor to be invisible. This is a reasonably recent API, so make sure you're using the latest version of FXGL. So we can now look around, and there is a cube there. I can press L to exit. You can also add actual camera movement. Just get camera 3D and get transform, and you can actually move the camera if you wanted to, but we're not going to do that. Instead, we're going to move the cube down a little bit at 0, 2, 0. So that we can actually see it's a cube. And also maybe move it closer to the camera. So Z is this way, so it's -2 maybe. Yeah, so it's a bit closer. We might make it bigger actually, and then we're going to animate it, or we'll do it the other way around. So let's animate it. Animations are quite simple in FXGL. If you've done any, then you know what I'm talking about. So we're going to rotate, and the good news is there is no difference between 2D or 3D animations. It's the same API. We're going to rotate our E being the entity. So note that the cube is not an entity. Cube is just a mesh, it's a shape. It's a 3D view of our entity. Entity is the game object, which means we don't necessarily need to have one view for one entity. We could have multiple views for one entity, and we're going to demonstrate that in this video later on. So rotate from point 3D 0, 0, 0. This is the default rotation. So the way rotations work in 3D in FXGL, they're Eulerian angles. They're not quaternions, and they're not matrices either. So what you do is you look at X, Y, and Z separately, and each value represents the rotation along that axis. So X is this way, like in, X and Y actually are like in 2D. So rotating along the X-axis is that way. Probably doesn't help them, kind of moving my finger around, but it's rotating along that axis. And you'll actually see this in practice. It's much better than me trying to explain this abstractly. So we're going to rotate from the default position, which is just 0. Let's rotate it along the y-axis so it spins like a trophy or something. So the y is the second value, and we're going to rotate to 360. So it's a seamless animation, because 0 and 360 degrees are the same thing when it comes to circles. Build and play. And then maybe repeat this infinitely. You can repeat a very, you can repeat a set amount of times, and you can also repeat infinitely. So we have a spinning cube. So the y-axis goes down, and then when you rotate along the y-axis, this is what you get, what you're seeing on the screen. Right, so hopefully this is doable. This is not a lot of code to achieve a reasonably decent effect. And we're going to take it up a level. And we're going to do that by splitting this cube into multiple cubes. So you know how FXGL basically is JavaFX. So you can use things like groups, which can group nodes. And because cuboids are nodes, you can add a bunch of cuboids into this group, which are now calling cube. We're going to go from 0 to... Actually, no, we're going to go from... We're going to rename this to Z. And then we're going to do that for each axis. So let's have 7, and then this is going to be y, and then this is going to be x. Let's define the size of each smaller cube so that it adds up to a big one. So let's do something like 0.3, and then small cube is where we create a cuboid with size in each of the directions, width, height, and depth. Small cube, let's set the color to gold. Make sure to translate that. Set translation. You can either set them separately or as a single value. And then x, y, and z are nicely given by these values. In fact, what we could do to make it nicer is go from -3 to +3, so that we go through the 0 value. 3, 3, and then this is -3. And then finally, I'm going to get cube, get children. It's a group, so you can add your own stuff. Small cube, and then the cube which contains all the small cubes gets added as a view to our entity. Now visually, this may not change a lot. We'll see. Yeah, so it actually looks like a single cube still, but it actually consists of multiple ones, which we can also animate separately, because they are nodes, and both entities and nodes can be animated in FXGL. So what we could do is, well, literally take this and then animate each cube separately. No, the small cube. Rotate. Well, instead of the y-axis, how about we pick a different axis to rotate along? That way, that would be x-axis, so 360. Maybe change duration to be 2 seconds. By default, it's 1 second. You can configure all of these. I suggest that you check out all the methods that you can call in order to configure your animations. Now, this is a slightly more interesting animation, and this is still fast. Let's slow it down a bit. Duration seconds 4. Move the thing close to the camera so we can see it up close. That's weird. It's now compiling the entire FXGL engine. Like, I haven't changed anything. Why would you do that? I haven't changed anything inside the source code. Anyway, while that's doing that, how about we talk a little bit about the API, I guess. So what I want to achieve now is maybe use a different type of animation. After all, the video says composite 3D animations. So instead of just using rotate and rotate, so we're rotating the entire thing as a single unit, and then every small cube within the group we can animate using a different form of transform. So think like scale, translation, or maybe even color. Color could be nice. So I'll finish, well, it'll finish compiling, and we're going to proceed. Meanwhile, well, I don't even know what to do actually. Meanwhile, it's almost finished. So yeah, it's doing this thing. Can look around, And this looks like a collectible actually, just because of the way it spins, I guess. I'm just so used to seeing spinning things in games where you can collect stuff. And it's also doing its own internal kind of rotation of each individual cube. Now, instead of rotating small cubes, how about we scale them? Rotate becomes scale, small cube. Again, it takes 2.3Ds from and to, where each value x, y, and z determine the scale of the view/entity along with that axis. So by default, it's 1, 1, 1 because 100% scale. And we can change it to something like 1.5, 1.5. So it's going to grow essentially. And then we're going, because it's an animation that repeats infinitely, we don't want it to go like this and then kind of immediately shrink to 1, because that's how animation starts. With rotation from 0 to 360, it's fine because it's the same thing. It does the full circle thing. But here, it's much nicer to have auto reverse set to true, because then it grows and then it shrinks, because it's just reverse. It's going to reverse the animation. Because it's doing it uniformly, as in every single cube grows and shrinks at the same time, I don't think it's very visible. It's quite subtle. So what we could do is add a delay so that each individual animation has its own delay. We're going to base that delay on some kind of an index. Delay index set to 0, and then every time we add the delay, we're going to increase that by 1. Delay index multiplied by some value that I don't know yet, and delay index is going to be increased by 1. So we'll multiply that by, let's go for 0.005 for now. Animations are trial and error most of the time. You want to see how it works. Okay, I'm going to move this like really close to the camera. How far is my camera? Because I remember I moved the camera by default to, there we go, that's better. So you can see that each cube now gets animated, well, separately because of the delay. And you can actually see how the cubes get formed because of the order in which the delay happens and the order in which they are animated. You can actually change the order. I mean, you can change the ordering inside the group. Therefore, you're changing the animation order. It's usually nice when it's symmetric. This isn't. So we're going to change that. At this point, it's more or less freestyle. I've given you all you need in order to be able to animate things in 3D. So from now on, I'll just add a bunch of things and hopefully they'll look nice. So instead of doing the animation here, I'm going to take children of the cube group. I'm going to sort them by something. So stream sorted. Comparator, comparing double. So I want it to be symmetrical, which means it needs to, how about we sort them from the center outwards. So there is a cube in there somewhere at 0, 0, 0. I think that's going to be the center. So comparing double, C, which represents the cube because we're doing streams now, get translation. because if we're going to take the distance to 0, 0, 0, then translate x, y, and z are going to be the values. So do I just sum them? How about that? And then we'll see how this goes. So this is going to sort it. And then for each cube, we're just going to do this. So we're basically separated the creation of cubes from animation of cubes. Delay index can't be used that way because it's in a lambda. So I'm going to move my delay index to here. It will be accessible from there. We're going to animate this thing, and let's see how this goes. Oh yeah, I didn't account for the fact that there are minus coordinates as well. I need to take the absolute value of each of those. And then it'll work the way that I think it should work. Yeah, you can see that it's now going from the center and then outwards. Now this looks like something. I can't quite pinpoint the actual object it looks like. The delay is quite small. Actually quite big, so make it smaller. Maybe like this, because we have a bunch of cubes, right? It's almost like 7 by 7 by 7. So it's doing something. We can also change the color while we're at it. Take this, most of it is going to be used anyway. We're going to animate. Well, color animation is not as easy because we need to get a hold of the material that this cube has, or each individual cube has. And first of all, we need to cast it to a cuboid, because currently it's a node, and IntelliJ needs to know that it's actually a cuboid. Then we can get a material, which is a Phong material, and then we'll be able to set the color. Delay, yep, we're going to use the same delay as the scaling. Duration, auto reverse, yep, repeat infinitely, perfect. Animate, material, diffuse color property. Another advantage of the FXGL animation system, it can animate properties. From color gold to something like, I don't know, blue, something that contrasts nicely, and then build and play. I think that's done it. Yeah, that's sorted. You can now clearly see the transition between colors and the scaling. You can also get rid of the scaling and then do rotations. Yeah, there are lots of interesting things you can do. You can also add interpolations, and this is where it really gets quite interesting. So let's add an interpolation to our scaling animation. Interpolator, interpolators, bounce. Quite like bounce because it's a bit more interesting than, its function is a bit more interesting than other interpolators. There you go. It's a different animation, shall we say. Oh yeah, and we can look around. I keep forgetting that I've added it. Okay, I think that completes the tutorial more or less. So one last thing, which is not really related to this, that going full screen, because that's kind of a thing that people want, particularly for 3D because it looks really nice. Plus we have the L key to exit the game, so we're not too worried about how to get out the game. So anything to do with settings, you change in init settings, and there are a plethora of settings to change. You can see that's lots of methods. So set full screen something. Set full screen allowed first, because we're allowing FXGL to go full screen. And then full screen from start. This can be set to false if you want to go full screen because of a menu event or something. Like you're in a game and then somebody clicks full screen and then you go full screen. But you can go full screen from start, like this. I don't know if it's being recorded properly, but it looks really nice. I think I've set the recording to 60 FPS, so it should look really nice in the video as well. Tesseract. That's the thing it looks like, right? If you change the color palette to more kind of blue, light bluish, that's the thing. I keep forgetting that. Anyway, so in this video we talked about how to use FXGL to create a 3D entity, how to animate the 3D entity using Animation Builder and all the methods that it provides us with. We also learned a little bit about composite views, so that we can use JavaFX as group class to group our own views and then use the group as the view of an entity. And finally, we sorted those views based on some custom criteria. I used the center point being the kind of first thing to be animated, and then it goes outwards. And we've gone through some different types of animations that we can run on entities or properties or nodes. On that note, I'll see everyone in the next video. Bye bye now.